The magnetic resonance imaging (MRI) machine is a sophisticated medical device that has revolutionized the field of diagnostic imaging. MRI machine utilize powerful magnets and radio frequency waves to generate detailed image of the internal structure of the human body. MRI scanner are particularly well suited to image the non-bony part of soft tissue of the body. This image provides valuable insight into various anatomical structures, including organs, tissue, blood vessels, and even the brain's functional activity. The MRI machine consists of several essential components, including a large magnet, gradient coils, and radio frequency system, and a sophisticated computer system. The magnet creates a powerful and uniform magnetic field, while the gradient coils introduce subtle variation in the magnetic field to enable spatial encoding of the signal. One electrical case related to MRI device involves the presence of ferromagnetic objects in the MRI environment. MRI scanners generate powerful magnetic field, and if ferromagnetic objects are brought into the MRI room, they can pose significant risk. For example, in 2001, a tragic incident took place at New York City Hospital involving a 6-year-old boy named Michael Colombini. The incident happened when Michael was undergoing an MRI scan. The incident occurred when a child who was sedated and positioned inside the MRI scanners experienced a rapid decline in oxygen saturation level. Due to the malfunction in the pipe in oxygen supply to the MRI scanner room, the attending anesthesiologist urgently requested oxygen. A nurse, who was not familiar with the MRI procedure, responded to the call and handed him a steel oxygen tank, which is a ferromagnetic object. Unfortunately, when the anesthesiologist brought the oxygen tank into the MRI scanner room, the strong magnetic field of the MRI scanner forcefully pulled the tank out of his hand, causing it to enter the scanner and tragically crushing the child's head, resulting in the death of the child. Next, I will go deep into the electrical test and safety of MRI machine. Firstly, grounding and electrical installation. Proper grounding of the MRI machine and associated electrical installation is crucial for electrical safety. This includes ensuring the machine is connected to an appropriate electrical supply with proper grounding to prevent electrical shock and ensure stable operation. Secondly, regular inspections of electrical components, wiring and connection should be conducted to identify any sign of damage where a potential electrical hazard. This helps ensure that all electrical components are in good condition and functioning correctly. Next, leakage current tests are performed to measure the amount of current that unintentionally leaks from the MRI machine. This test helps identify any potential electrical faults that could pose risk to patient safety. Next, the use of Biomedical ESA6158 assists in identifying potential electrical hazard, verifying grounding and bonding integrity, assessing insulation resistance, measuring leakage currents, and conducting functional tests. Then it will send the information to the computer. Besides, MRI machines are equipped with the safety interlocks that prevent the initiation or continuation of the scan if certain safety conditions are not met. This interlock may include checking the integrity of the grounding, ensuring appropriate power supply, and verifying the absence of the ferromagnetic object in the scanning area. MRI machines should adhere to relevant international standards, such as those set by the International Electrotechnical Commission (IEC) and ISO, for example, ISO 10974. In conclusion, the use of MRI machine requires strict adherence to safety measures and protocols to ensure the well-being of patient staff and the proper functioning of the equipment.